här gången tar sig äventyraren och klimatjournalisten Bernice till Alaska.
For 3.5 billion years, the climate on Earth has supported life, allowing species to diversify and flourish. In the last 10,000 years, this unusually stable climate has allowed the rise of civilizations and provided a home to 7 billion people. But the climate systems we depend on are becoming unstable. The atmosphere is warming at an alarming rate. And from the Amazon rainforest to the frozen tundra, our stable climate is heading towards tipping points. Scientists in groundbreaking research all over the world are trying to determine whether one small change in our oceans, ice sheets, or forests can tip the balance and change our world forever, inevitably, irreversibly. But how concerned should we be?
My name is Bernice Noteloon. I'm a climate journalist and adventurer. I've climbed Everest,
burning of fossil fuels. It's for the first time.
surface in the high Arctic is one of the most feared tipping points.
This is one of the areas that has the highest organic matter density. So if you took up a bucket of soil, there'd be more carbon and organic matter in that soil than almost anywhere else on Earth. So the organic matter here that's being washed into the river has been frozen for hundreds of thousands of years. And because of climate warming caused by the burning of fossil fuels, it's for the first time starting to decompose. So it's like waking a sleeping giant.
So the permafrost melt could be the mother of all tipping points, right?
Even worse. As this happens across the Arctic, in Alaska, Canada, in Siberia, this has the potential of really changing the way the whole climate system works. Scientists from all different disciplines are really concerned about this question. How quickly will this carbon be released and how much of it will be released?
Just how rising temperatures threaten to waken this sleeping giant, permafrost, is what Bernice is on an expedition across Alaska to find out.
This is where it begins, Bernice, the permafrost journey. I mean, you can see where it's coming off the land here. That's going to make it all the way to the Arctic Ocean.
The being released.
First stop on my quest to get some answers is remote Tulik Research Center in the high Arctic of Alaska.
Here in 40 days, which is just really off the charts.
We're flying out to Stinky Bluffs, a remote location that only a few people have seen.
Right now, scientific records and observations show that the Arctic is heating up faster than anywhere else on the planet. If all 8.8 million square miles thaw, it will triple carbon dioxide levels and accelerate global warming.
Just looks so much like fall already, huh?
Yeah, we're definitely into fall. Plants know it.
The thawing permafrost will further destabilize our climate system, leading to more extreme weather events around the world.
Oh, look, Ben, brown bears.
So I showed up at the site for the first time in the summer of 2011. It looked like a construction site out in the middle of the tundra. And I'd heard a lot about the site. And seeing this strange exposed ice face, it was like a landscape from a different planet.
It does, yeah, look at it. can't believe what I see here.
Isn't that incredible? This is the Stinking Bluffs.
Stinking Bluffs, yeah. Now, is that all ice?
It's ice and soil that was laid down over the last 50,000 years, and now, because of changing climate, is melting.
I mean, it just looked like sculptured.
Yeah, you can see layers. You really realize this is a huge time capsule. Important role in changing of soil and ice. This is the only feature like this in Alaska.
Well, where else can we see this?
There's a lot of this kind of permafrost in Siberia.
Well, I understand that you're wowed by just seeing this, but why is it actually so important?
What we're learning from sites like this is that permafrost has played an important role in changing the climate in the past, and that it may, again in the future, play a large role in amplifying the effects of human-caused climate change.
No, so what do you see? What do you find?
You can take soil samples from a site like this, water samples, and get an idea of what happens when the soil falls apart like this. Because this is happening more and more in this area and across the Arctic. And so we need to know how much carbon is going to be released and how quickly it will be released.
And what will happen if all this carbon will be released in the atmosphere?
We're talking about 180 years worth of fossil fuel emissions. You know, it's a huge amount of carbon. It would change the whole ecosystem.
So no wonder all the scientists want to come here and study this and put their hands in that ice. Eh?
Right, absolutely. I mean, you have bison bones coming out of it and mammoth tusks. It's a really stark example of what happens when the climate changes. You really can smell, that organic matter rotting.
It's like I'm standing in my garden and I just composted the whole thing.
I always think it smells kind of like mammoth dung. Yeah.
The stench of Stinky Bluffs is the smell of climate change. Climate history also shows that the global climate system can change very quickly. The data from Stinky Bluffs is crucial evidence that this has begun to happen now.
It's really exciting as a scientist to come to a site like this because we're climate and ecosystem detectives. We're looking for clues. We're going to be taking some soil samples. I'll use this stainless steel core. We want to know how much organic matter is in the soil, but quite a bit of material is coming off there. So we
Compact.
Yeah, I mean, it just fell 30 meters. Around here,
Yeah.
and how quickly it is released to the atmosphere after it's thawed.
Oh, can I touch it?
Try not to.
Okay.
So now that this 50,000-year-old dirt is above freezing, how quickly will the microbes munch on the plants and animal matter that are in there?
Oh, look at that. It's so compact.
Yeah, I mean, it just fell 30 meters. Bernice, I'm going to go grab an ice sample. Will you watch me again?
Sure.
Thanks.
Getting an ice core out of the base of the cliff will take even more time in the danger zone.
Hey, Bernice, we'll call this one Ice Core 2.
Yeah, but hurry up.
Freezing my hand here.
Now, how old is this ice?
We took it from near the bottom of the head wall, so it's probably in the 45,000-year-old range.
Permafrost scientists around the world are waiting for the analysis of these samples.
It's exciting as a scientist to come to a site like this. And one of the big things we're learning from the permafrost system is that it takes thousands of years to get organic matter into the soil. But that organic matter can be released in just a few years. 55 million years ago, the climate warmed 5 degrees over several thousand years.
it's important to realize that the scale and rate of change that we're talking about now is several degrees, 2 to 5 degrees in just 100 years. So this is much faster than has happened in the last 50 million years. We're talking about unprecedented climate change and a very rapid, abrupt response from this ecosystem.
That could push the global climate system to the tipping point and make larger storms, floods, droughts, and rising sea levels more prominent across the world.
I have a daughter who's 3 and a son who's 3 months. And it's interesting, it's no longer a question of if the permafrost region is going to change the climate.